December 19th, 3. I/ATLAS makes its closest approach. But 3 hours ago, everything changed. Scientists detected it, a massive wobbling structure 400,000 kilometers long, aimed at the galactic center. It's transmitting, beaming data home. Then Deep Space Network picked up incoming signals, not from the object, to it. Something out there is answering. The upload completes in 24 hours. What happens when they receive our coordinates? Let's dive right in. Look, I need to be completely honest with you about what we're dealing with here. For the past 48 hours, I've been going through the data, cross-referencing reports, and what I'm seeing keeps me up at night. This isn't sensationalism. This is what the evidence is actually showing us. It started with a preprint paper that appeared on the archive server 2 days ago. The researchers who wrote it were analyzing ground-based telemetry of 3I/ATLAS, and they found something that made them question everything. They documented what they're calling an anti-tail. And before you think that sounds like science fiction, let me explain what that actually means. In astronomy, an anti-tail is usually just an optical illusion. When Earth crosses through a comet's orbital plane, the tail can appear to point toward the sun instead of away from it. It's a perspective trick, rare but explainable. But what these researchers found wasn't an illusion at all. They detected a physical structure extending over 400,000 kilometers into space. To put that in perspective, that's larger than the distance from Earth to our moon. And this structure wasn't just drifting passively like comet tails are supposed to do. It was moving with purpose. It was wobbling. Now, this is where basic physics should tell us something's wrong. Comet tails are clouds of dust and gas pushed outward by the solar wind. They're passive. They flow and disperse. They don't maintain structure, and they certainly don't wobble in rhythmic patterns. But that's exactly what the data showed. Precise mechanical oscillations occurring every 144 minutes, right before the object reached its closest point to the sun. Dr. Avi Loeb looked at this data and published a commentary that's now circulating through scientific channels worldwide. His analysis is straightforward and troubling. Oscillations of this magnitude require momentum transfer. In simpler terms, something had to push back to create that wobble. If you're trying to stabilize something against the intense gravitational pull of the sun, you make course corrections. And when you do, your exhaust trail wobbles. That's not speculation. That's physics. What makes this even more disturbing is that the wobble pattern is completely independent of the object's rotation. If this were natural outgassing from a comet, the pattern would either be chaotic or it would sync with how the object spins. This does neither. It operates on its own rhythm, suggesting active control. Then the spectroscopic analysis came back from Chile's deep field arrays, and honestly, this is where things stopped making sense according to any natural explanation we have. The composition of this anti-tail structure is all wrong. Instead of the expected signatures of water ice and dust that you'd see from a comet, the readings show heavy elements and complex absorption lines that shouldn't be there. Some researchers are reluctant to say it publicly, but the signature looks less like a comet tail and more like some kind of magnetic exhaust. And here's what really defies explanation. This massive 400,000 kilometer structure is maintaining its coherence against the solar wind. Think about what that means. The solar wind is a constant stream of charged particles blasting out from the sun. Normal comet tails are torn apart by it. They're turbulent, messy, constantly dispersing. But this structure is cutting through the solar wind as if it's shielded, as if something is containing it magnetically. You don't get that kind of magnetic containment from a rock tumbling through space. Now, I want you to see something that made my hands shake when I first looked at it. This is the photometric light curve from the past 48 hours, data that was leaked from amateur astronomy networks. A light curve simply tracks how bright an object appears over time. For a normal comet rotating irregularly through space, this should look like a jagged, noisy mess. Light bounces off ice, then rock, then ice again. It's chaotic and random. But look at what we're actually seeing. The line is perfectly flat. Then it drops by exactly 0.4 magnitudes. Returns to baseline. Drops again. Returns. Drops. Every single time it happens at 144-minute intervals, the exact same frequency as the tail wobble we talked about earlier. When you overlay these two graphs, they synchronize perfectly. When the tail swings one direction, the object dims. When it swings back, the brightness returns. This isn't a tumbling comet. This is a mechanism operating with clockwork precision, and we're watching it happen in real time. That massive structure is swinging back and forth in perfect sync with the main body, which means it has structural integrity that clouds of ice and dust simply cannot maintain. If you tried to swing a debris field that size, physics would tear it apart. But this is holding together. Here's what keeps bothering me about the media coverage. Every news outlet is telling people to grab their binoculars for a beautiful celestial event. They're saying 3I/ATLAS is in the constellation Lepus, just south of Orion, and it'll be a once-in-a-lifetime viewing opportunity. But they're not explaining why you need binoculars in the first place. As an object approaches Earth, it should get brighter. More sunlight hits it, more light reflects back to us. Basic observational astronomy. By now, with an object this close, it should be visible to the naked eye, possibly even spectacular. But 3I/ATLAS is doing the opposite. It's fading, going dark. The object is absorbing roughly 90% of the light hitting it. A fresh comet with pristine ice should be bright and reflective. This thing has an albedo so low it's almost like looking at Vantablack in space. There are really only two reasons something would be designed to absorb that much light. Either it's trying to avoid detection, or it's harvesting the energy. If that massive tail structure is actually functioning as some kind of solar collector, a magnetic scoop gathering radiation, then it would appear dark because it's capturing the energy, not reflecting it. And right now, as we approach December 19th, it's at maximum deployment, positioned perfectly between us and the sun. This brings us to perhaps the most significant finding, and it comes from combined data from observatories in Australia and South Africa. They measured the precise orientation of this anti-tail structure, and what they found breaks a fundamental rule of comet behavior. The tail isn't aligned with the solar wind. It's off by 12 degrees. That might not sound like much, but in celestial mechanics, that's enormous. It means this tail isn't being pushed by solar wind at all. It's being deliberately aimed. When researchers traced that vector, following the line of that 400,000-kilometer structure out into deep space, they found it's locked precisely onto Sagittarius A star, the supermassive black hole at the center of our galaxy, the exact same direction 3I/ATLAS originally came from. The implications of that are staggering. This isn't a passive tail trailing behind an object. It's a high-gain directional antenna. And the wobbling pattern we detected? That's signal modulation. We're watching data being encoded and transmitted in real time as this object passes our planet. It's uploading everything it observed, everything it measured, sending it back to wherever it came from. And the timing of tomorrow's closest approach isn't coincidental. On December 19th, Earth passes directly between 3I/ATLAS and the Sun. For a brief window, our planet blocks solar interference, creating the quietest possible conditions for long-distance transmission. Or perhaps our gravity is being used to lens and amplify the signal, boosting it for the immense journey back to the galactic center. Either way, we're not just watching this happen. We're part of the transmission system itself. Which brings us to those deep space network logs from 3 hours ago that changed everything. For days, we've been detecting the outgoing transmission, that wobbling tail structure beaming data towards Sagittarius A star. But 3 hours ago, DSN arrays picked up something else, incoming signals. Not from the object itself. Directed toward the object. The signal pattern doesn't match any satellite in our inventory. It doesn't match any terrestrial source we know of. The transmission originated from deep space, coming from the same vector that the anti-tail points toward. After days of watching 3I/ATLAS broadcast its findings, something out there is responding. The scientific community knows this. Encrypted channels are flooding with analysis and debate. But the mainstream coverage, they're still calling it a beautiful comet flyby, encouraging people to look up and enjoy the show. No one's explaining that we're witnessing active communication between an interstellar probe and its point of origin. Tomorrow, the upload completes. Tomorrow, the alignment reaches its peak. Tomorrow, at a distance of 270 million kilometers, every major telescope on Earth will be pointed at this object. The evidence is overwhelming. The precision wobbling, the magnetic containment, the synchronized dimming, the galactic alignment. This is not a rock drifting through our solar system. The real question facing us now isn't whether 3I/ATLAS is transmitting. That's already confirmed by the data. The question is, what happens when the transmission completes? What happens when whoever sent this probe receives its full report on the third planet orbiting a yellow star, the one with liquid water, oxygen atmosphere, and electromagnetic signals filling its orbit? Does it go dormant? Does it adjust course? Or does it receive new instructions? We have less than 24 hours before we find out. Look, the facts are clear. We have a 400,000-kilometer structure wobbling with mechanical precision. We have dimming patterns synchronized to the millisecond. We have a transmission beam locked onto the galactic center. And 3 hours ago, we detected a response. Tomorrow, December 19th, this reaches its conclusion. The data upload completes. The alignment peaks. And we'll finally see what happens when an interstellar probe finishes reporting back home about the inhabited planet it just surveyed. I'll be monitoring every telescope feed, every data release, every update as this unfolds. You need to be here for it. Right now, hit that like button if this data convinced you something extraordinary is happening. Subscribe to Galactic Breaking News and turn on notifications. Tomorrow's coverage will be critical, and you don't want to miss it. Drop a comment below. What do you think that response signal means? Are we watching first contact in slow motion? Share this video. People deserve to see the evidence for themselves before tomorrow arrives. This is the biggest story in astronomy right now, and the mainstream media is calling it a beautiful comet. We know better. I'm Galactic Breaking News. Tomorrow, everything changes. Be here.